Yeah, so I'm going to talk about the PhD project of Sophia Borgest, who's really a child of Lifebrain. She's one of the traveling brains, and she will be giving this talk instead of me. She was co-supervised by Roger and myself. But the reason she's not giving a talk is that she's actually in the States now. She's now a management consultant, but she's still interested in global health. But her project was to look at lifestyle and the influence of lifestyle choices on the brain. So I'll talk about particularly physical health, grey matter, and fluid intelligence. And I want to cover three things. First, that physical health may be a factor that explains unique variance in fluid intelligence, and blood pressure is one of many markers of physical health. And you'll see, although the project started looking at lifestyles, it actually evolved into a study looking more at potential dissociations between cortical surface area and cortical thickness. Because in the second part, I'll suggest that these two measures of the grey matter mantle are dissociable. And then finally, talk about the implications of that for mediation analysis. When you use volume, you may be confounding thickness and area, because of course the volume is a product of the two. So we started by taking the CAM-CAM data, and in CAM-CAM we have a large number of measures of lifestyle, and we did an exploratory factor analysis, ended up with 5 factors, which we labeled physical, social, intellectual, educational, SAS, and mental health. We looked at whether they made unique contributions to fluid intelligence, and you can see that intellectual activities, education, SAS made unique contributions, but physical health did as well. And even when you residualize for age. Now, this is just an association. I'm not claiming any causality here. But the point I want to make is that note that, again, the physical health factor did load on at least systolic blood pressure. I'll come back to that later. But then we looked at various measures of the cortical grey matter, volume, thickness, surface area, also curvature, sulcal depth, fractal dimension, various other metrics that people have tried. I want to ask which of these relates best to age and to cognition. And so again, using CAM-CAM, we found that, as expected, cortical thickness decreases with age, as does surface area. But when we residualize with respect to age, so we take the Cattell score, Cattell is a measure of fluid intelligence, and we remove the effects of age, we no longer found an association between cortical thickness and individual differences in Cattell beyond age. But for surface area, we still found a positive relationship between your surface area and your fluid intelligence, even allowing for your age. So that was an interesting finding, but it was an exploratory finding, so we wanted to replicate it. So we used the LCBC cross-sectional data and found a similar pattern. So again, both thickness and area decline with age, but if you remove the effects of age, it seems to be surface area that correlates more strongly with here the WASI measure of fluid intelligence. But that's obviously just cross-sectional, so we wanted to look at longitudinal changes using latent change score modeling. So in both CAM-CAM and LCBC, we looked at the relationship between changes in surface area and changes in cognition, or change in thickness and change in cognition. And in both cases, you can see, I don't know if this pointer works, you can see that for the relationship is stronger for surface area, changes in surface area and changes in cognition than it is for changes in thickness and change in cognition. And if you compare those relationships directly, they're significantly greater in both cases for surface area than they are for thickness. And you can just see that here visually. So, and now we're putting change scores. We don't have to residualize with age anymore. We're looking at cognitive change against area change, strong relationship in both cohorts, but a much weaker, let's say, relationship between thickness, changes in thickness and changes in cognitive ability in both cohorts. So it may be that surface area and thickness are capturing different things. We didn't find much added value of things like curvature or fractal dimension. But of course, the point I want to make here is that if you're only looking at cortical volume, then you are confounding, of course, thickness and area. I know that Christine and Anders have talked about this for many years, but I think it's important to keep in mind. For the following part, the last part of the talk, where we looked at blood pressure. So I showed you at the start that we identified this physical health factor that explains unique variance in cognition beyond other factors, and systolic blood pressure relates to that. The problem we have is I think it's a problem in Lifebrain generally, is that the lifestyle measures are quite varied across different cohorts. And we didn't have, I don't think there are many cohorts with exactly the same measures as we had originally our factor analysis of CAN. But one variable that we do have at least longitudinal measurements on in many cohorts is blood pressure. So that's why we focused on blood pressure. So we wanted to ask, does grey matter mediate the relationship between systolic blood pressure and cognition? And if so, which properties of grey matter? So this is a lagged cross-sectional mediation. And of course, I'm not going to claim strong causation here, but the point I want to make is more about the nature of the measurements. So in CAN, we looked at whether the effect of blood pressure at time point T1 on fluid intelligence measured years later, time point T2, was mediated by grey matter at time point T2. And in CAN, there was a significant mediation effect, and that was replicated in LCBC of about a third of the variance explained by this mediation analysis. But this is using grey matter volume, which we know is a product of thickness and surface area. So when we separate area and thickness in both cohorts, we still find mediation effects on cognition. But if we look at age residualized fluid cognition, we now find a pattern in both cohorts where the solid lines are reliable paths and the dotted lines are not reliable. We can zero them in a substitution model and they don't make a difference to the model fit. So the summary of that is that, yes, systolic blood pressure relates to thickness. There's actually surface area that relates to age residualized fluid abilities at time T2. So by confounding volume, you find a mediation. Maybe that mediation is mediated, or there are different components of grey matter here that explain both parts of this mediation. So that's certainly a possibility. You may be wondering, why don't we do longitudinal mediation? Well, we did try. Unfortunately, at the moment, I don't think there's enough data points where you have 2 data points on both systolic blood pressure, grey matter volume, and fluid cognition. I think there's only 38 that we were able to get from LCBC, which is obviously very low power. If we look at just cognition at time T2, we now do find a mediation, although one of the paths is not significant. So we need more longitudinal data to test this in a longitudinal context. So that's it. That was the end of Sophia's PhD. So we found some evidence that cortical grey matter volume mediates the effect of blood pressure on fluid intelligence, but when you distinguish thickness from surface area, it appears that thickness is affected by blood pressure, consistent with some possible mechanisms to do with neurogenesis and increased dendritic complexity. But fluid intelligence is predicted by surface area, as we found longitudinally as well. So maybe there are dissociable causes and consequences of differences in thickness versus differences in surface area. So that's it. That's a summary of what I said, and happy to take questions now, or at the end, or now, whatever. Thank you.